5.4 Dividing polynomials. Just like how you've done long division in elementary school, it's the same concept. Example. You do not have to write this down, just showing that same thing as numerical long division, we're going to be going over polynomial long division. So we have our long division here. We have an x plus 5, and we're dividing x squared plus 23x minus 16. One thing that you see here is that each variable is being represented. If it's not, you have to replace it with a 0. Your main objective is try to match up your leading number here to this right here. You want to match it. So in this case, in order to multiply x plus 5, in order to match my 4x squared, I have to multiply that by 4x. And this number that you're multiplying by goes up top here. So I multiply that in. This becomes 4x squared. This becomes plus 20x. I write that right below my two terms. Now here's where it's very important. You are subtracting this whole thing. So you're basically distributing a negative to the first term and any other terms within them. Now with a subtraction, now when I look up and down, 4x squared minus 4x, that's just going to give me 0. I don't have to write that down, but you can. I have 23x minus 20x, which just give me 3x. And then the negative 16 just follows down below. So I look now, how can I match this term to look like this? I would have to multiply x plus 5 times 3. That's how I get to look the same. So I have my plus 3 here. So this looks like plus 3x plus 15. That goes right below it. 3x plus 15. And again, you have to make sure that you're subtracting, so you're switching the signs within them. So when I add or subtract these together, this becomes 0. This would be like a 0 here. Negative 16 minus 15 would give me a negative 31. There is no way that I can get this x to look like negative 31, so that would be like my remainder. How you represent your remainder is you have a plus, whatever is left goes on top over what you are dividing. So this right here would be my final answer. So if you look at these two problems here, I don't have an x in this problem and I don't have an x in this problem. Whatever you are dividing by, it does not matter if you don't have every term represented, but it does for what you would be putting underneath your long division. So I had 3x to the fourth minus 4x cubed plus 12x squared plus 0x plus 5. So I'm going to multiply this by long division. So first, how can I multiply this to look like this? So I have to multiply by 3x squared. So if I multiply that in, I get 3x to the fourth. Now when you're writing this, I'm going to have 3x to the fourth, and then you have to make sure to put the correct numbers underneath for like terms. So I'm going to write my 3x squared underneath my 12x squared. Remember, you have to make sure to switch your signs here. So now when I add these together, again, it's like subtracting, so switching the sign. These two cancel each other out. This has nothing to add to it, so that just becomes negative 4x cubed. And I have 12x minus 3, which would give me a positive 9x squared plus 0x plus 5. And now you look again. How can I get this right here to look like this? So I just multiply by negative 4x. And I forgot to write my 3x squared first, because that's our first number we multiplied by. You would have gotten negative 4x cubed and a minus 4x. Remember, you have to multiply by a negative 1. That's like switching the signs within. So if I add these together, these two cancel each other out because it's a negative and a positive. I still have my 9x squared. I'm adding here, so this would give me a plus 4x plus 5. And again, this is the number that is written up top, minus 4x. So now how could I get this again right here to match my 9? I would just multiply by 9. So I put plus 9 up top This gives me a 9x squared plus 9. I have to switch my sign. You have to make sure to do that. So I'd have a 4x minus 4. Now there's no way that I'm going to get an x squared to look like 4x, so this would be my remainder right here. So I'd have my plus 4x minus 4 over x squared minus 1. Now it says, is this a factor? Whenever you have a remainder, it's never going to be a factor. So this would be my answer along with no, it's not a factor. So the first two problems were long division. Now I'm going to show you a synthetic division. You can only use synthetic division if it's just a binomial, where it's just an x by itself and then adding, subtracting a number. It is a lot faster, and I'm going to write down the steps that you should write. First, you want to solve this for x. So this would be like x is equal to negative 2. Whatever this factor is goes in a box in the upper left-hand corner, and you would box it in like so. And then you look at what you're dividing by, and you take the leading coefficient, so the number out in front. So I have a 1, that represents with the x cubed. I have a negative 14, that's with the x squared. 51 is with the x, and then a negative 54. Draw a line here. And how you do synthetic division. You first bring down the leading number. So here's a 1, so I bring that down underneath. Okay, so that's where my 1 comes from. Then you take this number underneath this line that you get, and you have a diagonal right here. And then your second step, you want to multiply your number by 0. So in this case, this would be like 1 times negative 2. This number then goes right underneath your second coefficient, so this would be a negative 2. And then once you have that number, up and down, you're always going to be adding. So in this case, this becomes a negative 16. So now when I go diagonally, I have my negative 16 times negative 2, which give me a positive 32. Up and down I should add, so I'm going to add those two together and get 83. Diagonally, I'm going to multiply by negative 2, and I get negative 166. And then I add. If you get a number here, that right there is your remainder. So I'm going to add my negative 54 to it, and I get negative 220. So what do these numbers represent? So right away when I look at the numbers I started with x cubed. Once you divide, this number then are still the numbers out in front, but this becomes x squared. So this would be 1x squared minus 16x plus 83 plus, again, this is your remainder, negative 220 over whatever you divided by. In this case, it was x plus 2. So this is using synthetic division. And no, this is not a factor because this is going to be my remainder right here. Whatever does not perfectly end up as 0. So again, make sure that you write this down. When I'm dividing by negative 7, in the box we go a positive 7 because I'm solving for 0. The numbers out in front, I would have a 1 for x cubed. There's no x squared, so I have to represent that by 0. And negative 57 and 56. Remember, the first number always just moves down below. So in this case, it's going to be 1. And then I multiply. So I have 1 times 7, and I get 7. Up and down, I always add. So diagonal, subtract, or multiply, up and down you add. So this becomes 7. Now I'm going to multiply again. This becomes 49. So 7 times 7, that's where I got the 49. Up and down, I add them together, and I get a negative 8. Diagonally, I multiply, so it would be 7 times negative 8. It's always this number out in front, so that gives me negative 56. Up and down, add. There's no remainder here. So yes, this would be a factor in how I'd write this out then. I started again with x cubed, so this would be like my x squared, x in my number, so I'd have 1x squared. You don't have to write the 1 out in front if you don't want to. And this would be my answer. Because again, there's a 0 here at the end, so there is no remainder. Make sure you have all 4 examples.